Hello, this is the solution video for the live aid problem from BGOpen 2021. In the live aid problem, you are organizing a concert and you're given a set of musicians that want to perform at your concert. Each musician comes with a start time and an end time. This is when the musician wants to start their part of the concert, and this is when the musician wants to end their part of the contest. And each musician also has an attention associated with it. So the musicians are very stubborn. They will only attend the concert if they are allowed to start exactly at their start time and end their part of the concert exactly at their end time. The output you are asked for is to pick a subset of the musicians such that their start and end times don't overlap, and you want to maximize the total attention of the concert. Here is sample case 1. You cannot pick these two at the same time because they overlap. But you can, for example, pick these two because they do not overlap. So one solution would be to pick this one and this one, which would give a total attention of 9. But it's clearly better to pick these two that do not overlap, which gives a total attention of 12. This problem is actually the same as something called weighted interval scheduling or longest path in a DAG, and we can solve it with dynamic programming. We start by sorting the musicians by their end time. Then we define PI, the closest previous musician by end time of musician I that does not overlap with I. So in this case, P0 would be 2 because, 1 is closer to 0, but 2 is the closest one that does not overlap. Then we define our dynamic programming array. The element at index I is the optimal solution of the musicians from 0 to I. Then we have our algorithm. For each musician in increasing order of end time, we set dpi equal to the maximum of the previous one, which means that we do not include the current musician, and the one where we include the current musician. And if we include a current musician, we cannot include anyone that overlaps with that musician. So we have to combine it with optimal of the previous non-overlapping concept. So our answer will be in dp and stakes big O and log n. PI, we can compute this a few different ways, but we can, for example, use binary search since we're already sorting, and this also will take n log n. Computing the dp array is O of n. So the total running time is O of n log n.